All right, guys. So today we're going to be looking at our next day of notes, which is going to cover 9.2, and this will be over reflections. So to start off, what we're going to talk about is what a reflection is. So a reflection is going to be a transformation over a line, and we call that line the line of reflection. So it'll be helpful here if you guys are using highlighters. We're going to highlight our line of reflection every time that we're doing a problem. So my line of reflection, I'm going to highlight in yellow throughout the notes. And keep in mind here, this next part is going to be important. Each point on the pre-image and the corresponding point on the image are equal distance from the line of reflection. And I'll show you guys some examples down here. So to start off, we're going to look at what does a reflection in the x-axis look like. So my reflection in the x-axis here, there's my x-axis, that is my line of reflection. So let's say, for example, we have the point, let's say we have 3, 2. We have this point A. Well, what we're saying here is that, let me zoom in a little bit so you guys can see. This point here is 1, 2. So it's 2 away from that line of reflection. So when I reflect it, it also has to be 1, 2. So there's going to be our new point, which we're going to call A prime. Okay, so this is what we're talking about here with the equal distance. When you are looking at a point, when you're reflecting, it has to have equal distance. So from A in green, it is 2 units away from that x-axis, that line of reflection. So when I flip it, A prime, I'm just going to count 1, 2, because it has to be equal distance. Another way we can take a look at reflecting over the x-axis is with the following rule. So our coordinate rule, remember we start with x comma y, and then we have our arrow. This is our rule for reflecting over the x-axis. If I reflect over the x-axis, the x stays the same, but the y is going to change signs. So this will change signs. It says negative, but understand that that just means it's going to change signs. So let's take a look at the point A that we used. So you'll notice that point A has coordinates of 3, 2. If I apply that transformation, so in other words, if I apply that reflecting over the x-axis, then what we get here is A prime. And you look at A prime, the coordinates of A prime are 3, -2. So hopefully you guys are seeing that from our original point, our rule is going to be that the x stays the same, the y changes signs. So here 3, x stayed the same, so it's still 3, but now the y changed signs. So that's how the reflections over the x-axis work. You can just use this coordinate rule or notation. So this part here is the rule that we're using for reflecting over the x-axis. All right, so let's take a look at reflecting over the y-axis. Well, my y-axis, if I'm going to reflect over the y-axis, then this is the y-axis. One thing I didn't mention earlier is that this guy right here is the equation for the x-axis. Okay, the equation for the x-axis is y equals 0. Now, if I look at reflections in the y-axis, keep in mind here that we're just going to pick a random point here. So let's pick, I don't know, let's do -2, 4. So let's say this is point A. Or let's use a different letter. Let's say this is point P. Well, remember, when you're doing reflections, you're counting how far away is it from the line of reflection. My line of reflection is the yellow line, the y-axis, because that's what they're telling us, in the y-axis. If I count, then we see that point P is 1, 2. It's 2 away. So when I reflect it, I'm going to also count 1, 2. So there's going to be our new point, P prime. Also 2 away. So our coordinate rule for reflecting over the y-axis, here's my x comma y. The notation that we're going to have here is if I reflect over the y-axis, then the y stays the same. Now the x changes signs. Okay? And so this will be your rule. Okay? This will be your rule, kind of like a formula that you can use. And we'll see how that works later. So for example, if I look at point P, P has the coordinates of -2, 4. If I apply this rule, okay, and I'm not going to do it like I did the last example, if I apply this rule to that, then what's happening here is the x is going to change signs, okay? Here we're saying that the x is going to change signs. So if I have P as -2, then when I go to P prime, it's going to change signs and become +2. And then we say here that the y stays the same. So it's going to stay the same as 4. So that is going to be P prime. All right, next one that we have here is reflecting over the line y equals x, okay? Keep in mind that now the line y equals x, this is in the form of y equals mx plus b. So in this case here, remember m is your slope, b is your y-intercept. So what I'm looking at here is the slope m is the number in front of x. Well, there's no number written there, but there's technically a 1. The y-intercept is the number that comes after. There is no number, but I can write this as +0. So for this problem here, okay, my slope here is 1, and my y-intercept, b, is 0. Now, when we're working with slope, we want to have a fraction. So I'm going to turn this slope of 1. You can always turn it into a fraction by putting it over 1. So to start off, whenever you're graphing equations like this in y equals mx plus b, you start with the y-intercept first, b. So I'm going to look at my y-axis here, and I'm going to start with my y-intercept at 0. Now what we're going to do is we're going to use the slope, m, and this tells us that we're going to rise 1 and run 1. So I'm going to go up 1 over 1. There is my next point. Up 1 over 1. Up 1 over 1. Up 1 over 1. So that's plenty of points. What we're going to do now is we're going to connect it with the straight line. Okay, you can use your ID to draw a straight line a little bit better than mine, but there is the line y equals x. So that is our line of reflection. So that's our line y equals x. So the thing that's different about this one is now, let's say, for example, we want to reflect this point. We'll go back to A. Okay. Let's talk about the rule that we have first, because normally we would count, but I can only count up and down and left to right. I can't count here just down 3 and then down 3 again. I have to go diagonal, but I can't count that way. I can't count diagonally. So we're going to use a rule instead. Your rule for reflecting over the line y equals x, what ends up happening is the x and the y change places. So now it's y, comma, x. So what you'll see here is if I take that original point A, which is 2, 5, remember this is your x, this is your y, what we're saying here is when we transform it and reflect it over the line y equals x, these guys are going to switch. So now instead of 2, 5, now we're going to have 5, 2. And this is going to be when we reflect over the line y equals x. Next, we have y equals negative x. This will be similar to the last one that we did, the line y equals x. negative x, sorry, is also in the form of y equals mx plus b. So remember, m is the number in front of x. There's technically, when there's no number, there's technically always a 1 there. So we can write in a 1. So my slope here is -1 this time. And then our y-intercept, similar to the last one, we can write it as +0. And remember the slope, this guy? We want it as a fraction, so you can always write a number as a fraction if you put it over 1. So to graph this one, you're going to start with the y-intercept now, b, which is 0. So find your y-axis. Your y-intercept here is 0. And now if your slope is -1, 1, I'm sorry, -1 over 1, you're going to go down 1 over 1. So from that point that we have on the graph, go down 1 over 1, down 1 over 1, down 1 over 1. And we can connect that with the straight line. Okay, so that right there represents our line y equals -x. So for y equals -x, now we can actually start looking at an example. Let's say this one right here is, we'll do something different here. Let's say I got point x here. Let's not do x, maybe let's do q. Our rule for reflecting over the line y equals -x is the following. What you're going to do is you're going to change the order of y and x, and then you're going to flip both of them. So flip the signs of both of them. So let's look at q, for example. Point q has 4, 6 for the original point. If I'm going to apply this rule to point q, the first thing I have to do, this is an x, y, I have to switch the order first. So now I got 6 and 4, but now I need to make sure that I flip the signs, because this is talking about, here we're talking about negative, or flipping the signs. So instead of +4, I'm going to write -4. Instead of +6, -6. And so that will be q prime. So let me write that in there. That's q prime. And that's how we do our reflections over these lines. Honestly, these right here are the hard ones to do. The easier ones are when we're reflecting over the x and the y axis. Let me scroll back down there. So the first two are easier. The last two are a little bit more challenging. But let's practice with some examples, and then we're done for today's notes. So here it says, reflect point A, 1, 0. So 1, 0 is right here. Reflect that over the x-axis or across the x-axis. That right there is, when they say across, that is your line of reflection. So my x-axis is right here in yellow. So remember earlier we said when we're reflecting, it has to be equal distance. Well, that line is, that point is on the line of reflection. So if that part's confusing you, consider the following. 1, 0. When we're reflecting over the x-axis here, look at the rule that we had earlier. Reflection in the x-axis here used this rule. We're going to take the x, keep it the same, and then flip the sign of the y value. So if it's reflecting over the x-axis, the rule we have is going to be, we're going to take the x value, keep it the same, but now we flip the y value. Okay? If I do that here, a prime, well, the x stays the same, so 1, but now we flip the sign of the y value. Well, the y value here is 0. There is no such thing as positive or negative 0. 0 is just 0. So our point after the reflection ends up being 1, 0. It ends up being the same. We call this a fixed point. If it is asking you to reflect something and that point is on the line of reflection, it's not going to move. It's going to be fixed. It's going to stay. Let's look at a few more examples. Let's look at number 3. It says reflect point A across the line indicated. So here, okay, it's not labeled, but this is supposed to be point A. So this right here is point A. So let's look at what point A is, okay? Point A is, if I count 1, 2, 3, comma 1 is the coordinates. If I want to reflect over the x-axis, they wrote the rule down here for you. If I want to reflect over the x-axis, keep the x the same and change the sign of the y. So in this case here, A prime would be 3, comma, now change the sign of the y, so instead of +1, -1. Similarly here, now if I do reflecting it over the y-axis, now here's our rule down below in blue. We're going to follow that rule. So that rule for reflecting over the y-axis, A prime is now going to have us with the x now changes signs. So instead of +3, -3. And the y stays the same, so it stays as 1. So if you use the rules, it actually makes doing these reflections a lot easier. And you can plot these points on the graph now if you want. A prime is 3, -1. So 1, 2, 3, -1. Here's A prime. And it makes sense here because here is our x-axis, the line of reflection. See how it's 1 away for A and also 1 away for A prime. Then they asked us to reflect over the y-axis. And we got, for A prime, for that one, we got -3, comma 1. So -1, 2, 3, comma 1. And just to check our answers here, look, notice how this is 3 away, and this is 3 away. All right, let's go ahead and keep going. You guys will get a better hang of this with some more practice. So next it says, reflect point A across the line indicated x equals 1. When you have an equation in the form of x equals a number, then understand that that line is going to be vertical. That's how you graph it. So x equals 1, you're going to count on the x-axis. You're going to find 1. 1 is right here. That equation, x equals 1, is going to create a vertical line that looks like this. So for this one, we don't really have a rule for x equals 1, but that represents our line of reflection. They want us to reflect point A across that line. So point A is right here. If you count, it is 1, 2 away. So when I reflect it, 1, 2 away. That's going to be A prime. And the coordinates of A prime is, remember now, this right here is where we started. That's the origin. So your coordinates are going to be -1, comma 1. Next, we have reflect point A across the line indicated y equals -1. So now I'm looking at this line here. If your equation is y equals a number, then we're looking at a horizontal line. So go to the y-axis, and we're going to find -1. It's right here. So that means the equation y equals -1 is going to create a horizontal line that has a y value of -1. And now we can do the same thing we did earlier. Look at the point A. If we're going to reflect that over our line of reflection, we have to count. How far away is A from that line of reflection? Well, if we count, it is 1, 2. So when you reflect it, it's got to be the same distance away, so 1, 2. That makes A prime be located right here in red. So if I count, we have 1, 2, 3, comma, -2 for our A prime. And I didn't put it on the last one, but I need to. For the last one, that would be A prime. Oh, and you know what? I didn't even count right. Let's just go ahead and make sure we're doing this carefully. It's easy to mess up. I just messed up right now. When you're counting and putting the numbers for the point A prime, make sure that you're doing that from the origin, from the original. So when I plot my point, this should actually be, it is 1, 2, 3, but I'm going down 1, 2, 3. So it actually should be 3, comma, -3. Sorry about that. Okay, so next we have example 5, reflect triangle MNO across the line y equals x to become triangle M prime N prime O prime. So let's fill out the points for M, N, and O. I'm not going to take a lot of time going through this because we've done this a lot of times already. So the coordinates for M are going to be -8, 4. N is going to be -3, 8. O is going to be -4, 2. All right, so here they're asking us, hey, reflect, and you got to read carefully, across the line y equals x. If you go to your notes at the beginning, we said that our rule for reflecting over y equals x, this was our rule. This meant that you take the original point x comma y and you just switch them, switch the order. So what we're going to do here for M prime, N prime, O prime, we're just going to switch the order. So if I switch the order, instead of -8, 4, 4, -8. Let's do this in a different color. So we got 4, -8. Just for the rule y equals x, you're just going to swap the order. This is what we're doing. So then we got 8, -3, 2, -4. So now, let's plot those points. We got 4, -8 right here. That is M prime. Then we got 8, -3. Here is N prime. O prime is 2, -4. If I connect these, there is our new figure. There's the image. And remember the line y equals x? This actually looks something like this. So it does look like it flipped over that line. Okay. This next part says find the slope from each segment that could connect M to M prime. So remember, slope here is rise over run. So let's check for M to M prime. We're going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going down 12 and to the right 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and going over 12. So our slope here for that would be written as -12, because remember you start with rise. The rise we went down 12 and then to the right 12. So -12, 12. And that just gives you 1. Then you can check it for N prime. For N to N prime, so from here to here, you're going to count and you're going to go down here in this case 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I think we're good there at 11. And then now we're noticing we're going over 1, 2, 3. Let's actually write that. For this one, it is down 11. And then to the right, we were counting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we get -11 over 11, which is -1. Sorry, that last one should be negative. Guys, you'll end up realizing that O to O prime, you can count and check for yourself. It's also going to be -1. Okay, just to finish up here with the last part of the notes here, it says reflect point A across the line y equals -x. Say. So earlier in the notes, go back and check from that table earlier. You got this section right here for over y equals -x, and this is the rule. So our rule for reflecting the point A across y equals -x, this is our rule. We have x comma y, and what happens is the x and y swap places, and they change signs. So let's take a look at A. If I look at A, the coordinates are 3, 1. So if I apply this rule here, what we're doing first to our x and y is we're going to switch the order. So now we're going to write it as y comma x. So 1 comma 3. But now I need to change the signs. So that becomes negative. If I change the sign of this x, it also becomes negative. So A prime is going to be -1 comma -3. Okay. Guys, y'all can skip the last part here. What I would rather have you guys do is begin working on Delta Math. So what I want y'all to do, again, is go to Delta Math. You don't have to write this in your notes. I'm just telling you what to do. Go to deltamath.com like we did yesterday and work on homework 9.2. So it'll say 9.2 reflections. Homework. Okay? If you guys have any questions or anything like that, please reach out to Ms. Flores, ask one another, and help each other out. I'll be back on Monday to help answer any questions if you guys have any. Have a great weekend, and I'll see you soon.